Hi everyone, welcome back. My name is Ananth, and today we're going to be talking about linked list. And this is going to be the first video in a short series on an intro to data structures following the syllabus taught at the University of Maryland for CMSE 132. So to start off, data structures are simply a way to organize and store data. We've seen this already with arrays where we have an array of particular type and we can store several values inside of it rather than creating separate individual values. And one thing we'll notice moving forward is that each data structure comes with its own pros and cons, and we'll have to vary our usage based on the type of data we're handling as well as the situation at hand. The linked list in particular is a linear data structure where we have a sequence of elements called nodes that are connected using pointers. So one node object, you can imagine, looks like this, and it has an instance variable containing some data, which is in this case an integer value, and it has a pointer to the next node. And same goes for these as well. And then finally, we terminate by pointing the last or tail node, making its next pointer to null. And unlike arrays, this doesn't require contiguous memory, and we instead store the memory address of the next node object within the current object itself. The pros and cons of linked list include dynamic sizing, where it's very easy to insert and delete elements from the linked list as opposed to an array. And this comes with the drawback of access being slower, and storing the memory address of the next node can be a little bit tiresome at times as well. And there are three types of linked lists, including a singly linked list, which is what we've been talking about so far, where you only have one next pointer, and where we start with the head and end with the tail node, which is denoted by having its next pointer to null. There is the doubly linked list, which stores not just next pointers, but previous pointers as well. So in this case, the head has its previous pointer set to null, and the tail has its next pointer set to null, and everything in between just has the arrows going both ways. And we also have a circular linked list where we don't use null at all, and by the end of the linked list, the tail simply points back up to the head. Now that we've gone over some relevant definitions, we're going to be manipulating a singly linked list by writing an insertion method to insert at the head. Now that I've made it to Eclipse, I can go ahead and get started. And the first thing to note is that I've already defined the class for the node object, giving it instance variables, a value, and a pointer to the next node, as well as a constructor that takes in a parameter for value, sets it, and then sets the next pointer naturally to null. And I'll go ahead and get started first with the implementation of the linked list object we're going to be using. And this is just going to be creating a node object, which points to the head. And this is very common practice. Usually you don't have a reference to every single node object. That kind of defeats the purpose we defined earlier. We only have a reference to the head and sometimes the tail of a linked list. So now that I've defined this head, I'll go ahead and get started on the method. So when we're adding to the front of a linked list, first thing we need to do, given the parameter value, we want to create a new node. So I'm going to say new node is equal to a new node. And now that we've created this, we have this node, but as we see, the constructor sets its next value equal to null, meaning it's not part of our list. So we're just going to set the new nodes next to the head of our current list. So new node.next. And now that we've done this, we've actually successfully added to the front of our linked list. But as I mentioned, linked list and data structures you'll see in general, we have most of the time a reference to only one value, and we want this to continuously be the head. So I'm going to update the head to point to what is now the new head, because since we've added to the front, and say head is equal to new node. And that's it for the method, and I'll go ahead and test this out. First, I'll instantiate this object, and now that we've done this, I'll call our method a few times. And now that I've done this, I've called our method 3 times with 0, 10, and 20. I'll print what we have. So list.printlist, and this is a method I defined here below. And we can run it to visualize our results. And we've successfully created the add to front method. Finally, to recap, linked lists are linear dynamic data structures where we have a node object that stores its own data as well as a pointer to the next node. There are 3 different types that we'll be focusing on, including singly, doubly, and circular linked lists. And I encourage you guys to practice the insert remove operations on paper and really get an intuitive sense for what's going on. That's it for today, and I'll see you guys in the next one.